Okay, so thank you. I'm Silvia Puca and work at Italian Civil Protection, and today I will show you how we use satellite precipitation products and also other precipitation satellite products in early warning systems. So, as I said, sometimes, okay, so the mandate for the civil protection is to defend lives and property by damage or by possible damage due to the natural and technological disasters and other destructive events. So the risk management is composed by mainly three phases. The first one is the prevention, but we are more focused on the prevention in the first part, so it means to identify the needs, requirement, the risk mitigation, and of course the emergency plans. But we are during this presentation, we will be focalized more on the second phase, forecasting and surveillance, and this is composed by event location and risk assessment, and the post-event phase, the emergency management, that is concerning contrast actions, aid organization, and damage assessment, of course. So the question today is, satellite data can provide an effective contribution to hydrological hydraulic risk management, because of course to cope the mission of the civil protection we employ different satellites and different technologies, and that satellite is very important and can really contribute. This is the question. So that means that we would want to know if the data are available with the features that we need for this scope, and if the time latency is congruent, efficient with the request of the alert system, and also if the accuracy of the products are enough for a local alert level. So during the phase of the monitoring of the events, so during the forecasting and the monitoring of the events, generally we use EUMeTrain data and also other data coming from GPM, NASA, and JAXA. During the post-event emergency management, we use other satellite data coming from ESA, of course, services of Copernicus and Italian Space Agency that can provide us information on the land characteristics and features. In particular, in this presentation, I will focus on hydraulic and hydrological risk. Unfortunately, in Italy, we had a lot of this kind of events, so our territory is affected by landslides and also by floods. And here you have the maps of some of the last years, and you can see that, unfortunately, more or less in every part of our territory, we had events related to landslide and floods. So how we can alert the municipality, how we can alert the population for provide them information useful for their safety. So what we do is to publish a hydraulic and hydrological bulletin forecast on this risk for the next 12 hours, 24 hours, and 36 hours. As you can see, this is an example of this bulletin, and we have divided the territory in different alert zones, and inside of each of these zones, we indicate which is the risk alert level. We use two levels. This is a yellow for the lower, and red for the maximum, orange for the medium. So which is the main difference is the fact that for the yellow, when we put the yellow risk alert, that means that generally the municipality can solve alone the problem in their territory. When there is a red, the maximum one, that means that also the national level has to be aware and ready to provide support to the affected municipality and areas. This is a methodology that is used by the very European civil protection. How we can provide this forecast, this hydraulic and hydrological forecast? Of course, the first parameters that we need coming from meteor forecast. For this, we use global EUMeTrain model, but also local model. And the same as for the hydraulic risk, we have a bulletin related to the meteorological events. And inside this bulletin, we report which will be the main meteorological events forecasted for the next 12, 24, and 36 hours. And also we have available the quantitative precipitation forecasted for that period, for those periods, for all 3 periods. And also we have information about the meteorological events. But it's not enough to can really provide a risk alert and assess which is the response of the territory if really these meteorological events will happen. And so we use, as many other European, also very easy pressure method with the return period for each area. And we need to introduce also antecedent conditions related to the soil moisture saturation. Otherwise, we are not able to provide a hydrological and hydraulical risk assessment. We need also the monitoring of what is happening when the event starts in order or an early warning to the local areas. So here I present a case study and we present how we work it. This is related to an event that we had in Sardinia, Italy, the 10th of October 2018. As you can see, we had the forecast of Saturday and what really happens. We have the Saturday flow in the western Mediterranean, and then we have also very warm air masses. And this generates a strong thunderstorm system, in particular in the south part of Sardinia, in that part. So we had this forecasted precipitation. This is the bulletin related to this event. You can see that we have the more intense forecasted precipitation in the center, middle part of the island. And we have also some precipitation in the north and the south, and this precipitation is related to convective precipitation with the occurrence of the lightning. So this is the forecast that we received from meteorological point of view. What we do generally, what we can do to have an information about the antecedent condition on soil. So generally, many European organizations work at also national level work using the antecedent precipitation in the last 5 days or 10 days, measured by ground network, generally by rain gauges or by radar data. So here we use also ASCAP data that can provide us information on the saturation of the soil. And this is a product inside H SAF. And also we use models that can assimilate the ASCAP product and give us also information about the level of saturation over the land, so in the soil. So if we had used the antecedent condition using The rain gauges, for example, in the previous 5 days, we have this kind of forecast, this kind of precipitation occurred, and so this is the bulletin related to the hydrological and hydraulic bulletin related to this event. If we use 10 days, we enlarge the area, not only the medium, but also the north part of the island. But if we use also ASCAT data, ASCAT product, sorry, we can see that the wet conditions are present also on the south part. So we know that generally this kind of meteorological event are effect of a latency difficulty to really be correctly localized in the time and in the space. So when we receive forecast on events related to convection, we have to be aware that it's very difficult to be sure about the localization and the time and the space localization. So on the base of the lower of the soil condition, also these other parties, of course, introduced in the bulletin using at least the model with the assimilation of ASCAT product. We have this kind of alert. So the red one is in the middle and in the south part. So we obtain different forecasts using different antecedent conditions. Now we start of the event. So we enter in the second phase, surveillance and monitoring. Generally in Italy, as in many other countries, we use to monitor the precipitation, the rain gauges, and we have more than 2,000 of rain gauges, a ground radar network that which can cover more or less all the Italian territory, and also we use satellite precipitation products. But the question is, it's really useful to adopt the satellite precipitation product. They really can match the requirements necessary for the monitoring. So they are this product in real-time products. The spatial and time resolution is able to follow convective events. That means that we know that are localized and smooth, and they have a fast developing. So here we have summarized the passages of the satellite that we had in that day, and these are microwave satellites, so satellite with microwave sensors on board. And we can see that for some hours we have more than one. Like in this case, we have 2, 3 passages or 1 passages. In some hours, we don't have any kind of passages, so information from microwave point of view. That means that for our purposes, we cannot use these products. But as colleagues showed yesterday and today also, we have also in H SAF microwave and infrared blended product, H03, that is available as which the features, the characteristic of the severe data of Meteosat second generation, so is available every 15 minutes, every hour, and with a special resolution of around 3 kilometers in our latitude. So we start with the monitoring that we had in our operational room at national level and at regional level. So in the upper panels on the left, we have satellite H03, so the blended product, infrared and microwave, with the overlapping of the lightning. That is very important information to be related to the severity of the events. And on the right, we have the radar estimation of the precipitation. In the lower panel, we have the rain gauges measurements and in the station. So here we can see how we move on the time. We have the evolution of the precipitation, of the convective precipitation seen by the satellite and the radar. And the main convective parts that are captured by radar are also detected by satellite data. Of course, as also some other colleagues, as Jan, as Marco and Leo showed also the previous presentation. Generally, we have an overestimation of the area and an underestimation of the higher level of precipitation. But the pattern is evident, and also the most part that we have the higher precipitation. So this is the continuous of the events. We can see that we have precipitation in the south part of Italy, so not in the middle as the forecasted said us, but we was aware that can happen with the convective precipitation and convective events. So the event is snow claw, it's not finished, we still have precipitation, still have the maximum in the same part of the region, and we received also in that moment the first information about floods in that region, and the precipitation still remain, and the convective nucleo and the convective intensive, more intensive parts still remain in the same part of the island and increase in the time, involving also the other part of the island and the middle part. The occurrence of the lightning and of the satellite, the precipitation can advise us that this is really an intensive event. This is what happens. So we had here in the south part floods, and this is the part that highlighted with one of the intensive precipitation of that we had at the 12th. With the H03, and we had also the cumulated precipitation, and here is still the part where we had the maximum value, and here I reported the hydrological risk at municipality level evaluated by satellite data, because I said before we are interested about the municipality, and so for this reason we aggregate generally the precipitation over municipality. And this is the comparison with the rain gauges municipality, so the rain gauge precipitation aggregated at the municipality level. Here we have more municipality in red line, in red colors, so in higher level. So what we had during the event, this part where we had the maximum of the level from satellite precipitation. In the same time, we had the antecedent condition related to the soil, so with very wet condition in that part, and this is the reason that we provided really this bulletin at the end, at the first hours of the event. So from the beginning of the day, we'll, thanks to the precipitation estimation and with the soil antecedent condition, we provide an early warning to that red region. To close, we can say the cycle of the risk management. I provide here also the floods area monitored by Sentinel-2 products, And this is the zoom in the part, and this is how we work. So after that, we had in the post-event, we have the monitoring also using satellite data, Sentinel-2 in particular, and we can overlap directly this information in our system with rivers, with hospital, with school, railway, streets, and that helps us to understand where we have to firstly have a check of the situation when we have a large area. So that's all, which we are some conclusion. What I showed you is not theory, but it is what we did. And so for the forecast space, to evaluate the antecedent condition, it is important to take into account the soil index evaluated by satellite data as ASCAP data, and so ASCAP product as the one available inside the project H SAF. Monitoring the satellite precipitation estimation derived by microwave and infrared data provides useful information for an hydrological risk monitoring at the local level, and this is very important for us. The estimation from satellite are available in near real time, every 50-60 minutes, and with an accuracy that is of around 3 kilometers. So is compatible with also convective events and not only stratiform precipitation events. As post-events, still satellite can help us because flood maps are available for the surveys by Sentinel-1 and Sentinel-2, and so they can help to understand which are the area which was much affected by the floods. So that's all, thank you, and this is my email also for the future.